Okay, any questions about the linear programming? Graphing equations, shading those equations, figuring out the feasible region, plugging the corners of the feasible region into an objective function to maximize. Okay, write these two equations down side by side, not next to one another, side by side. So x plus 2y less than or equal to 5. And x minus y less than or equal to 2. Write those four equations down. These two equations on the side, x is greater than or equal to 0 and y is greater than or equal to 0, forces the graph into quadrant 1. If you think about the graph of x is greater than or equal to 0, that is the y-axis. It crosses the x-axis at 0. So x is greater than or equal to 0 is a vertical line. Y is greater than or equal to 0 is a horizontal line because it crosses the y-axis at 0. So y is greater than or equal to 0 is actually the x-axis, and x is greater than or equal to 0 is actually the y-axis. How do we solve this equation over here? For y. What do we have to do, Ethan?
You have to
Subtract x. We can do that on the second equation as well. So we'll subtract x from all four sides, as the case may be. Then we get 2y less than or equal to negative x plus 5. What's the next step, Hayden? To get this y by itself. So what operation in between is multiplication? So to undo it, you divide by 2, divide by 2. So we get y is less than or equal to negative 1/2 x plus 2.5. Remember, you can always stick the 1 in between this negative and the x so that you know your slope's down 1 right too. On the equation on the left side here, we have negative y is less than or equal to negative x plus 2. How do I get rid of that negative in front?
Multiply by negative.
We can multiply all three parts by negative 1, or divide all three parts by negative 1. For whatever reason, I like doing that better. So when we divide by a negative, what do you have to do to the inequality? Flip it. So don't forget to flip that inequality. And I'm just going to make it 1 over 1x. So you have a frame of reference for your slope, minus 2. I'm going to grab these two equations and copy them to a new page. Did anyone still need that previous page though? Yeah, okay. I'll give you a second on that one. So remember, these are the two easiest when you're writing the equations yourself. These are the two easiest ones to forget. We'll do a problem later on today with t-shirts and sweatshirts. And the reason you have to have x and y is greater than or equal to 0 because you can't have negative t-shirts or sweatshirts. And they will not tell you to write these equations anywhere. You just have to remember them. So this big problem we're working up towards, we'll start one today, finish it Tuesday, do one more on Tuesday, and then continue to work on it on block day. Okay, there's a lot to do with these things. But you can't have negative whatever we're talking about. In this case, t-shirts and sweatshirts. So that's why you have these two equations up here. Okay, so we are going to graph these things. I'm only going to show quadrant 1 when I graph, because that's all we're graphing is in quadrant 1. And then you'll see how involved these problems get. You only have 7 problems for your homework, so that's always an indication the problems are going to be longer. So we're going to go up 2.5, so 1, 2.5. From there, we're going to go down 1, right 2. So down 1, right 2, down 1, right 2. And then draw that line. And just so you know, I'm starting to record these, the video lesson. It'll record every keystroke I make and sync it with audio. And I post those to every lesson, so in case you miss a lesson, you can have a video lesson as well. And give me, so it's been a while, probably 3-4 years since I did the video lessons. I know from previous experiences with the video lessons, me using the little cursor to point, because you can't see my actual arm pointing, you just see the little cursor on the screen. So if you give me feedback about, like, use the cursor more so I know what you're talking about, because I can be like, oh, divide by -1, and then the cursor's over here. That's not helpful. But if I move the cursor here, divide by -1, then you can see what I'm talking about. So as you watch those videos, give me feedback on that. And I'll show you where I load them on the page itself, just so you know. So we have the first one graphed here. That's the y is less than or equal to -1/2 x plus 2.5. Graph this second equation in red. So we start at -2. My slope has me go up 1, right 1, up 1, right 1. I'm going to go one more time, up 1, right 1, and then graph. So that blue line up here, we're going to shade above or below? Below, because it's less than, don't make that difficult. So it's either in this tiny little triangle or that tiny little triangle. Well, that's technically not a triangle. What's that called? An irregular shaped four-sided figure. Irregular. Yeah, somebody said it. Who said that? Nico? Quadrilateral, right? How about if we have two sides that are the same length? What's it called? Looks like a kite. We call it a kite. How about if four sides are the same but they're slanted like a parallelogram, but they're the same side? Begins with an R and then an H, rhombus. Okay, red line, do I shade above or below? Above. So we would shade here or here, and then the place where the arrows point towards one another is this area in the middle here, okay? So we need the corners of this feasible region. So we need any place on the edge of the feasible region. So those three ordered pairs. What is this top ordered pair by the y-axis? 0 what? 0, 2.5. Because this y-intercept is where this crosses the y-axis. So 0, 2.5. That's our first ordered pair. Then we have an ordered pair at 1, 2, 3, 1. So 3, 1. And lastly, we have an ordered pair at 2, 0. So we are going to use these three corners of the feasible region. We could use 0, 0, but if I'm maximizing something, obviously that's not going to be the choice. So I'm just not going to do that one. But let's look at our objective function, which is right here from the previous slide. P equals 2x plus y. You could think of P to represent something with profit. So we're going to plug in these ordered pairs, 3, 1. So when I plug that in, I get P equals 2 times 3 plus 1, which equals 6 plus 1, or 7. Okay, so we'll write that down real quick. So we're just plugging in 3, 1, one of the corners of our feasible region right here, into the objective function. That's all we're doing. Yeah.
So if that works, if like
Yeah, for sure. We can plug in 0, 2.5. We're plugging in all the corners. So that is p equals 2 times 0 plus 2.5, which equals 2.5. And then the last order pair we need to plug in is 2, 0. So do I need to plug this in, 2, 0? Because I already have a bigger x value, right? 3 is bigger than 2, and 1 is bigger than 0. So if I'm trying to maximize, I don't need to plug in that point, because both x and y are bigger on this point, right? So this function is maximized at 3, 1 as the order pair. What value is it maximized? It's maximized at 7. So the function is maximized at 3, 1. The order pair 3, 1 at a value of 7. But you can just write and circle the answers. Just don't make me a big list of these and let me figure it out, because I'll might take points off. Okay? You have to indicate in some way that you know which is the maximum amount. Okay, let's do another one of those. Let's do this one. I've been doing the same ones all day, so I'm going to mix it up a little. Again, write these top two equations next to one another, not stacked, because we're going to solve them both. So we get 3y less than or equal to negative x plus 9. It's one of our equations, and y plus 2x less than or equal to 8. I need to solve this first equation here for y. What do I have to do, Spencer? Divide by 3 on both sides. So we get y is less than, again, I'm going to stick that little 1 in between the negative and the x. So negative 1/3 x plus 1. So you guys will find these video lessons super helpful because, not because you're going to listen to the whole lesson again, but let's say there's one example on here you didn't understand well. You can listen to that same example a couple of times until you get it, right? Or even better, listen to it a couple of times, still have a question, then come back to me and ask. Yeah? It was, thank you. Negative x plus 9, my bad. So we're going to divide this by 3, and we get 3 right here. Okay. Was that the other hands up? Okay, good. Thank you. And what are we going to do to the second equation here? Subtract 2x from both sides. So we get y is less than or equal to negative 2x plus 8. Then we can grab those two equations, copy them onto a coordinate plane. Don't forget to write those two equations. That's what forces it into quadrant 1. And let's copy these. So we're going to only graph quadrant 1 because of that x and y is greater than or equal to 0. So we're going to start at positive 1, 2, 3. We'll graph that one in blue. We'll graph the second equation in red. So our blue line, we're going to start up 3 and go down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Down 1, 1, 2, 3. Sometimes when you do these problems, it's a good idea to count out your slope until you get down to the x-axis, because a lot of times you need to know where it's going to cross the x-axis, so it just makes it a little easier on you. And then we can draw our line in. Second one, we're going to start at positive 8, so 4, 5, 6, 7, 8, and go down 2, right 1. And it's a good idea, right? I counted out my slope until I saw where those two lines are going to cross, because we're going to need that information as well. So down to right 1, and then I also counted all the way down to the x-axis. Again, making it easier. So now we're going to draw that line in. And it's less than both, so where do I shade?
Corner.
In the little corner here, right? Yeah. So shade in that little corner. So what is that ordered pair? 0, 3, right? You know that from this y-intercept to 0, 3, because it's the smaller of the two y-intercepts, right? This one was 3, this one was 8, smaller one is 3. These lines cross at 1, 2, 3, up 1, 2. So 3, 2 is where the lines cross. And this one crosses at 1, 2, 3, 4. 4, 0. So the two equations which we haven't talked about but are still shown graphed on here is both x and y are greater than or equal to 0. So just don't forget those. Now we have our objective function p equals 4x plus y. So what's the only point of the three I'm not going to need to plug in of these three? Because if I look and I think I'm multiplying whatever x value I have by 4 and then just keeping my y value, which is going to give me the smallest value? 4, 0. So 4 times 4 is 16. What another idea? What's going to give me the smallest on here? 0, 3, right? Because 4 times 0 is 0 plus 3, I'm going to get 3. So I'm just going to show that real quick. So 0, 3, p equals 4 times 0 plus 3, which equals 3. Then we're going to plug in 3, 2. So we get p equals 4 times 3 plus 2. Then I can plug in 4, 0. So we get p equals 4 times 4 plus 0. So up here we get 14, and this one we get 16. So the function, the order pair that maximizes is 4, 0, and it maximizes everything at 16. So 4, 0 at 16. Yep.
How do you get 14 and 16?
I just did 4 times 3. The question was how do you get 14 and 16? 4 times 3 is 12, plus 2 is 14. 4 times 4 is 16, plus 0 is 16. Good. Good to ask. Any other questions? All right, we have to have one little, I didn't realize this because I chose the other of the two problems. I got to show you something on the calculator. So bust out your graphing calculator and plug in, just plug in that equation, y equals negative 3x plus 7. Yeah, do it in y equals, yep. Remember this negative down here on the graphing calculator? This negative is different than the minus. You can see how different they are by looking, right? The first one I just typed is negative, second one is minus. Doesn't matter if you have it in y1 or y2, none of that matters. Just put in negative 3x plus 7. And what we're going to do is figure out where this graph crosses the x-axis. So if yours is still on less than or equal to, you just want to go to the left side of y1, hit enter, and then you go down to these options, and that's what changes it. Okay, so that's the smaller of the two lines. Anyone need help with anything? You should have your plots off. Only time you need plots on are when we're entering data. And then if you want to get back to a regular window like I have right here, just hit zoom 6. It gets you into a window where -10 and +10 are both min and max for x and y. So zoom 6 to get back here to the regular window. We can have him on the video. Should I hand him the microphone? I think he's talking to mommy. Okay, Dick, anyone need more time? Yeah. We just forgot the negative as well. You got 2 negatives, that's right. There you go. Okay, anybody else need help on that? So here's what we're going to do. We're going to hit graph first, make sure your window looks like mine. Anyone need help on that? Oh, good. We're getting slightly better at the calculator. That's a bonus. Not too much help. Why something smaller? That's negative. Smaller it is, let me pause as I help people. It's not a waste of time. Okay, ready? Now you got to focus second, trace again. And what we're going to get is a 0 because it has a value for x, but it has 0 for y. That's why it's called a 0. When x has a value and y is 0, it's called a 0. So we were trying to find the 0. So you hit enter. And you notice that your calculator asks you this question, left bound? Like they're dumb. You already hit enter. Do it again. Second trace number 2. So left bound. I'm moving the cursor using the right arrow down to just above the x-axis. So if I think about as this dot right here, the little cursor, this blinking cursor is on the left side of that arrow, right? So I'm going to hit enter. It's above the x-axis. I'm going to go right arrow until it's below the x-axis. Hit enter once more. Then down here, where it says left bound, it'll say yes, and I hit enter again. So left bound, enter, it asks me the question right bound, hit enter again, then it asks me yes, hit enter again. You should get 2.33, so if you did it, you got 2.33, you're good. So it's still asking me left bound, I'm going to hit enter, and you'll notice that my calculator gives me this little dotted line. Now I'm below the x-axis, so I hit enter once more. Then it says guess. It always irritates me it says that, but it does. And then we get 2.33 down here. So where does this line cross the x-axis? It crosses the x-axis at 2.33. Okay? Yes. All right, hold on. Okay, so you just have to know how to do that and get a 0 because your lines may not always cross the x-axis at like a specific number spot. Okay, now I want you to write down t-shirt, sweatshirt with this information. Takes 10 minutes to make a t-shirt, 30 minutes to make a sweatshirt. We're printing t-shirts and sweatshirts. Supplies for a t-shirt costs $4, sweatshirt costs $20, profit, t-shirt $6, profit, sweatshirt $20. So get that stuff down. You also need to get down that t-shirts, let's just rate it on, I'll rate it over here. So you have at most 20 hours to make t-shirts. So 20 hours to make t-shirts. You want to sell, or you have 600 for supplies. you want at least 50 items. You want to sell at least a combo of 50, not dollars, a combo of 50 t-shirts and or sweatshirts. Could be all t-shirts, all sweatshirts, just kind of depends. So with the remainder of the time, the only thing we're going to do is write the equations for this problem. So the first two easiest equations to write are the equations that tell us you can't have negative t-shirts or sweatshirts. By the way, X is going to be t-shirt and Y is going to be sweatshirt. So those two easiest equations that are really easy to forget are what? To make sure we have positive t-shirts and sweatshirts. What are those equations? We've talked about them left. X is greater than or equal to 0. And Y is greater than or equal to 0. So if you forget to do that on your quiz that's coming Tuesday, you'll lose 1 point on this problem. This problem will be worth 10 to 15 points on your test. So like about 30% of your test grade will be this single problem. Just to give you a frame of reference as to what's going on here. What was your question, Shannon? Tuesday, yeah. Next. Okay, so we need one equation per minute. If this right here is 20 hours, and we're talking about the fact that it takes 30 minutes to make a sweatshirt and 10 minutes to make a t-shirt, what's the problem with 20 hours? What do I have to do to it? Make it into minutes. How do I translate $20 into minutes? 20 times what? 20 times 60. So if you are multiplication challenged, you can just do it in your calculator. 20 times 60. We know we need 1,200. So if we have 20 hours to make the t-shirts, what's the inequality? Less or greater? Less. Can it be exactly 20 hours? Yeah, it can be exactly 20. So I'm going to write the 1,200 over here. Actually, I'm going to move it up a little to keep things lined up. So 1,200 less than or equal to. And then how long does it take to make a t-shirt? 10 minutes. So 10x plus what? How long does it take to make a sweatshirt? 30y. Okay, so when they give you these little tags, you know you're going to have one equation for minutes, one equation for supplies. The objective function, the one we're trying to maximize, is almost always the profit. So we've got the number of t-shirts. So that's at least 50 items down here. So if it's at least, what is that, greater or less than? At least is not less. Greater. Right? If I'm at least your age, I'm your age or greater. So at least 50. Do we know how many t-shirts or sweatshirts for what goes here? So what do you write if you don't know either? X plus Y. Just easy. Don't make it harder than that. You don't know either. There's no like number that goes along with. It's just X plus Y. And then the cost. This is really the cost of the supplies. So how much does it cost to make, well, first of all, how much do you have for supplies? 600. And then can we spend more or less than 600? 600 or less, so less than or equal to. And then how much is supplies for a t-shirt?
$4.
$4, right? Right up there. So 4x plus 20y. Last, our profit equation. So what's the profit on a t-shirt? $6. Profit on a sweatshirt? 20. So you just get P equals 6x plus 20y. So we're going to graph and shape the first 5 equations, so 1, 2, 3 from up here, plus these 2 over here, which force us into quadrant 1. And then we're going to take the corners of the feasible region and plug them into this profit equation. We're going to do that tomorrow. Finish this problem tomorrow. Do one more full example, start to finish, and then I'll give you homework time tomorrow as well. Okay, any questions on this? Moral of the story, what did you learn today? What is the topic? Linear programming. What does linear programming do? Look at everybody reading so well. You're to find minimum or maximum value of an objective function given some constraint equation. Okay? That is it.